You're welcome to start, Chao.
Okay, hi everyone. My presentation is cartogram with topological features. And first we'll talk about the background and the motivation. Our previous work is try to combine the geo-spatial information with the high-dimensional multivariate healthcare data. So we transfer the original UK map to a cartogram and implement the healthcare data on each single node to create this we call cartographic tree map. This time we just focus on the cartogram. So you can see this is the original UK map. We just using the central point of the original map and increase the size of each node until and using the overlap removal algorithm to remove the overlap during increase. So finally we generate the cartogram. So you still can see there is some similarity between the original map and the final output. But we are thinking, could we do something more about the cartogram? Is there some way we can reduce the error and increase the recognizability of the cartogram? So we go back with the original map and thinking, could we introduce some other geospatial information in that map? So we think about to increase some rivers. For example, that's three kind of the biggest river in UK. So we're thinking if we introduce that river in the map and using this as a constraint of our cartogram, does it help to increase the recognizability of our cartogram? So we introduced the idea of the topological features. This is some idea we used from the flow visualization. It's referred to the edge of the curve so that separates and connects the different regions of the flow. So in our project, we use a topological feature that separates the unit area into different regions and make the cartogram to more legible and to reduce the error. So you can see the green line is the topological river feature we used. Here is the pipeline of our implementation. In the pre-process, we first input the river data and system data in the QGIS with their shapefile. Then we do the river approximation and definition in that process. Then after we generate the river, we implement all this data into our software and first we compute the central point and increase the node size. When the region has the overlap between its neighbors, we're using the overlap removal algorithm to remove the overlap. After that, we test for the river intersection. If the position of region have crossed the river, we use a topological preservation algorithm to remove the intersection and then go back to remove the overlap. So if there is no overlap and no river intersection, we can still increase the size of the node until it's reached the maximum size or reach the boundary. We finish and generate the final cartogram. So first we talk about how we define the river. and do the river approximation. As you can see, the river flow sometimes flow on the boundary of each CCG, sometimes this flow across the center of the CCG region. So we use a parallel node to define a segment of the river. For example, here, if the river flow on the boundary of two CCG regions, we use these two central points as a parallel node. So here we record the O8C and O8X as one pair of nodes. And here you can see the river flow just inside this region O8P. So, but the central point is on the right side. So we choose O8P and O8Y as another pair of nodes. So that's how it works. So after this process, we can go to a few pairs of nodes. We can implement this in our software. We connect each pair of nodes from the very beginning to the very end. So you can see there is several blue lines here, and then you can connect to all the central point of this blue line and generate the river as a topological river feature. Then we talk about how we test for the river intersection. As you can see, the dot line rectangle is the previous position, or we can say the last position. So you can see here, we suppose this time the river is still on their side of the region is still on the side of the river, and in the current position here, we connect the line between the current position and the previous position. If this line intersects with one segment of the river edge, we can call it river intersection. So in this case, previous time is on the right of the river, and the current position is on the left of the river. So we will push this region back to its previous position to keep the preserve the topological position. So we generate the pushing direction and pushing it back. But sometimes when this region has some neighbors, and after the overlap removal algorithm, this region will again push back to this position. So sometimes if we did nothing, this situation will happen forever and can't increase the size. So if we test for that situation, we will push all these neighbors, for example, the right rectangle, to the same pushing direction. The test range, this range, can be modified by the user. So here is some example for final output. This one is the uniform size, and this one is without the topological preservation algorithm. So you can see there are several errors. We mark it with cross. So you can see all these regions at the very beginning is on the above part of the river, and now it became to the bottom. And here's the output with our topological preserve algorithm. So you can see there is no error. and this one is the cartogram with size map to the population. So still this one is without the topological preserve algorithm, so there are several errors, but this one is no errors. We also provide a user option that can sense the width of the river. So in this case, the central point, the distance between the central point and the river will send to the 10. So you can see it's not just a test for the river intersection, it's test if the distance between the central point and the river is less than 10, it will be pushed. So you can see on the central point, the distance between the river is should somehow larger than 10. Here is the demo value. By the way, there is an error in the final videos I somehow just figured out today. So first is how we do the river definition and approximation. So this is the original river we input from the shapefile to the QGIS software. So you can see there is several nodes on both sides of the river. So we can figure out a pair of nodes from the very beginning to the end. After we figure out the pairs of nodes, we can generate the topological river in the cartogram. So here is the river definition. We generate out the green line for the pair of nodes and using the central point to jam the river. And this time we just use the previous algorithm to create the cartogram. So there is no topological preservation algorithm. So you can see there are several errors. At the very beginning it's on the top and now it's on the bottom. Yeah, that's the error as also text somehow. And this time you can see the pushing line when we try to figure out the intersection using the pushing line to push the regions on its pushing direction. So as this one is, in this case, the size of the region is mapped to the population. This time there is no preservation algorithm, so we say there are some errors. In this case, still the pushing direction, pushing the other its neighbors on the pushing direction. also the colors just indicates the different house card information. So you can choose any house card information you want. In this case, we set the river width to 10, so you can see the intersection test happens not on the river, just near the river. So it's quite clear here. To make the algorithm a little bit easier, this time we didn't push the region back to its previous position, but just up and down. So you can see mostly the pushing direction is straight. And for the future work, we're thinking about first we should invest more topological features. As I mentioned, we can introduce some other rivers, or some trees, tree lines, some mountains, some roads, and also we can provide an in-depth user feedback study. Does that help the user to increase the recognizability of the cartogram? And also, we should combine some more house card data if we can derive some interesting patterns alongside the topological feature. For example, alongside the times, is there some difference between the house card situation? Yeah, that's it.
You say you want to test some more topological features. Have you got any examples?
Not yet. Yeah, I'm thinking. Yeah, I can test the more topological features separately, but I currently cannot implement two more features in the same approach.
Any other questions for Chao?
You display only one river example, so is it possible to have more than one since it's representing the topological information?
Yeah, it should be, but I'm never possible.
So why did you select this specific region? Is it because it's so dense or just?
We just using this region as a starting point, so we're thinking is that is the most famous features in UK. So if you can recognize this river, it's help you to recognize all the nearby neighbors. And yeah, it's definitely can increase your recognizability around this river. Yeah.
Any other questions? What do you mean by topology?
For the topology, I mean there's a line or some curves that can separate a flow with, or some connect the regions of the flow. But in this case, I mean the topology is try to use to separate the regions, and yeah, is just used to separate the other regions, which is on the different sides of the river.
How about this one? Why are cartograms useful?
Cartograms useful.
Yeah.
Let's go back to the previous one. Yeah, the cartogram, for example here, in the original map, there's some information will be missed because the size of some regions is quite small. But in the cartogram, we can increase the size, and where you can see the more detail and the more information in that section. That's also it can present the geo-spatial information, so you can still figure out some geo-spatial data from the cartogram and combine with other information. Yeah, that's the answer.
What is a cartogram?
I should remember. What's the cartogram? I forgot the original definition of cartogram.
That could be that question could come up during your talk or during your viva.
Yeah. Cartogram. I can remember last time. This time I forgot. Yeah, I should write a sentence here. The definition of cartogram. Let me check.
It's an area by value map. That's the definition. I don't know if we actually defined it there, but
Yeah.
that's what you want to remember. Area by value map.
I remember last time I had a phone displaying geographic information by resizing a map regions of the status family to remain as still present the large recognizability. Yeah, last time I remember this one. Completely forgot.
Did everyone understand Chao's algorithm?
I think the videos, I remember seeing them before, and it was very clear, but when I was looking at here, it took me a second to realise that you were actually showing the debug one, because I couldn't see the outlines of the squares. So I'm not sure if anyone else did or didn't notice the actual boundaries.
They were there faint. They were very clear.
Yeah, it took me.
There's another slide.
It took me the second example to realise that it was the same thing that I had seen before. But it was. I assume it's just because of the projector and the light. But it still needs to be taken into account.
Another. This is here. Is clear.
Yeah. So if you come over to the back where I am, you'll understand what I mean. Oh no! If you just leave it like that, just pause it and come over here, you'll see how faint the actual areas are.
Yeah.
Because I couldn't see anything for the first example specifically, and then when I noticed it, it was a bit easier. But it was, even knowing it, it was still difficult to see.
So in this time,
Yeah, if you come up to the back by me, you'll be able to see what I mean. It might be easier because you're right beside it, but like from here, it's very difficult to actually see anything except for the blue line.
Okay, I can increase the depth of the boundary.
Yes, just increase the opacity or something. I think that would go well. Opacity. Sorry, Dylan.
Yeah, even in my computer is like, it's hard to see.
Just increase the line thickness a little bit.
No, there's all many different colours. That's
If
why
the
it
project
must be
and the
the
conference
opacity.
good, you don't need to change
Yeah,
it.
I can try
You
to
can try
the
it.
pixel of the boundary.
The visual, they are good.
There's another one of the slides that had a similar sort of thing.
Yeah, when you introduced the river boundaries, I thought you just introduced the rivers by themselves, and I was thinking, why don't we put that on the map? And then I was like, oh, it is on the map. It's just very hard to see.
Yeah.
So
Even in the point torch is the same thing?
if you go up to slide 3, yeah, that one.
Okay.
Yeah.
Yeah.
So I just recommend putting them on top of each other. So you talk about the map, and then
Show
when
them.
you want to show the river, just put it on top of the
okay.
current map.
Okay. Yeah, that makes sense.
I have some suggestions.
Yeah.
So I would suggest if you have outline slide for the presentation, and also some of the slides have the slide number and some doesn't. And for the comparison slide, I would suggest that you align the two maps together and remove the menu because it's not clear to read. And maybe put a small title.
You mean?
I think slide 8.
Yeah, this one.
Yeah, so align the two maps together and remove the menu maybe, and put, for example, under each one, for example, this with applying the river, this without. And if there is enough space, you would also add the X boxes and say error or something, because if someone is not like capturing the information from you, he won't be able to recognize that from the slide.
Yeah, I can write some text to mention this is the error.
I don't know if there is enough space. Well, there is enough space, but it might be a bit confusing if they're side by side. But I'd probably put a line between them, like a diagonal line. And I agree with removing the user options. You can't read them, so they're a bit confusing. And also you have like half the color map on the left one because you've overlaid it. So it's just stuff like that.
I thought it's part of the map.
Yeah.
Yeah.
It's that's on the half color map is on the other one as well.
Because I try to figure out how to place these two maps and take the most space.
Yeah, try to crop the image more. Yeah.
You can just go over the green line too. The green line is not some.
If you ignore the green line on one of them though, then why have you followed it in the other ones is the problem.
Yeah, I can.
I do put stuff over the green lines all the time. Nobody's ever gotten like a heart attack or anything.
I remember. Next time you present, that'll be my question.
Why is your image covering the green line? Yeah? Nobody else has a problem, any other problems with this slide? I'm surprised.
The title.
The spelling, yeah, spelling error. Comparison.
Yes. I think there's another one with in the video.
Yes, there are two. There are two that have comparison misspelled.
Okay, nice.
You got a spell check after the.
No, it's not giving. It's remove the TI, and then just add an S. That's what I'm missing. That should at least give you the spelling error. Just try an S.
Still. Comparison of this one. This one?
No.
No.
That's
You can just copy and paste it around if you want.
This one?
Does anyone have questions about the data? Like you said CCG, and
Yeah.
is it just because you've all seen his stuff before that you happen to remember what a CCG is and stuff?
Well, I feel a bit biased because I don't think the underlying data is the. He's like very similar to me, where I see the shapefile as the data. Whereas
It's more about algorithm.
If anything,
rather
I
than
thought
it is.
visualization.
It is.
If this was going on too long, I would have not talked about any of the data at the end. That would be something I cut out. So
Okay. Well, I have a note here that says like, what is a CCG, and just like maybe briefly describe your data. Just something to think about.
Yeah.
Maybe this audience is a little bit biased.
But depending on the time he took, how much?
That's true. That's true. Yeah.
2 minutes over.
Yeah.
Is it?
2 minutes so
If it's 15 minutes.
Or maybe he could refer to his previous work for more information.
yeah.
Mhm.
Okay, I don't not just bad for that.
see Chao with that.
I have some suggestions for please or slide 5.
Fine.
Yeah. Is this the image from the paper?
Yeah.
Okay.
Is it like ring the bell for your like line?
No, so just the yes and no for the testing. I think they should be closer to the actual node that
Okay,
they're
so-
related to.
Yeah.
So just move that node a bit closer, but the yes I think needs to go underneath because that's actually not the right bit of the flowchart. Even though the whole part is like the yes section, that's not where the actual condition is done.
It's a test.
You
So
mean-
the yes should here.
Yeah.
It should be where the no is, like, so the you have the yes and no going off two different directions. So the no comes off to the right, where the yes should come off at the down.
Yeah.
Yeah.
Also, I have something in this slide. You separated the pre-processing and runtime by this dashed line.
Yeah.
You said river approximation is a pre-processing.
Yeah.
Then compute the center points of the river approximated
Yeah.
as at the runtime. Why is that? Why you haven't done the
Yeah.
computation of the center points in the pre-processing, since you have the river approximation?
I think it's a bit different in this context. We're processing this stuff done before the software runs.
Okay.
Yeah.
So runtime is when the software is running, I assume. So the
Yeah.
actual when the algorithm starts. So, but yeah, I can see whether we can.
How are you doing the approximation?
Just for the first question, actually I'm thinking as the computer central point, we can start to present central point in the runtime, and the computer compute the central point in the pre-processing section. So here, actually, what actually means is just we implement now the central point on the output and begin as a starting point and try to increase the size of the node. So yeah, computing the central point should in the pre-processing part. And another question, the second question, how we do the river definition and approximation is that we manually to select the pair of the nodes and try to input it as some kind of CSV file and easy to read in the software. Yeah.
You could do it as like the input phase and output phase, if that was the case, rather than pre-processing in real time. Where the input phase is where you gather all the information, and then the output phase is where you start doing stuff with it.
Okay.
I think because, well, I mean, I'm just thinking about this in terms of how to make the least work for you to do. What you'd have to do is write over those titles instead, if that was the case.
Yeah. Go to
Any other questions or comments?
Shall I 12? Yeah. I just see something small, like, I think you should start with capital letters. Like, the first one will be
yeah.
Yeah, that's true.
You also don't need periods there because you don't have sentences.
We can make it as a polygon.
Yeah, I just don't know how to create a bullet point here.
Over. Is it the other way?
Right.
The other way.
Right.
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 This one?
No.
You see the alignment before, just above the
Keep going
alignment.
right. Keep going right.
Yeah.
Up.
This one?
Yeah.
Yeah.
No,
Oh,
no,
yeah.
no. The one next to it.
Oh, it's this one?
Yeah.
There we go.
Oh, okay. I just don't know how to do that. That's more.
I think also in slide 4 you need to make the sentences the same alignment.
Yeah. Huh?
This
Yeah,
one.
yeah.
Yeah.
This one.
I think I would just eliminate the top one actually about the flow. I think I would recommend just removing that completely. You don't want to get into a discussion of flow topology.
Yeah.
If somebody asks like what's the origin of this topology, you can say see the paper for details.
Yeah.
But it's inspired by flow topology. You could say inspired by flow topology if you want, but I think I would just remove that altogether actually, because nobody's going to understand and it doesn't really help. It doesn't really help. Yeah, it's just going to confuse everybody.
Yeah.
Well, is referring to the paper like a satisfied answer? Is it like satisfying answer? Are they going to be satisfied? Just like that, go to the paper and check it out. And
No, it's not a very.
You just say, I'm not quite sure about my phrasing in the paper.
it's
So I don't want to contradict myself.
well, I have your paper with me.
It's right, it is right here.
If there's an emergency, I will step in. But I can't do that during your Viva, by the way. I can't step in. But I can in the conference.
Just for the question I asked, I didn't really have an example that I wanted, but like something like mountains would be another topological feature.
He did say that in his final slide. He said mountains, roads, and
Oh, he did say that.
Mm.
Okay.
That's what I thought.
Oh right.
You were listening.
I was thinking, oh, I should ask this as a question.
I think that that's a valid question, and I would be prepared to answer that.
Yeah.
So when he said, do you have more examples, you would say yes, more rivers, roads,
Yeah.
and maybe, I don't know, maybe something else.
Try to.
But you do want to have some answer for that.
Yeah.
And the other good question was why this example, why the one river example, and I think it would be good to have an answer for this too. And I would just say because the Thames is the most popular river in the UK, so we decided to start with that.
I
Yeah,
think
he
it's fair to
mentioned
say
that.
you also already
Okay.
had the data from the UK
Yeah.
as well, so it was a good starting point because you just put the two together.
I would say Google it. We did Google it though. We did.
Okay.
We Googled things like popular rivers in the UK. Yeah.
I think it might be more effective if you use like a motorway M1 or something like that. Kind of goes up.
Yeah, I would argue that's future work.
Oh, yeah.
One
But
question-
like I don't drive cars, so I don't look at the motorway maps.
Yeah.
I'm used to just looking at geographical maps without the motorways, kind of.
Yeah, I guess. Roads tend to be the most prominent things on maps. Like if you go on Google Maps, it's the roads you see, it's not primary roads sometimes.
I don't know, like that would be a good user study.
Yeah.
So if I say, here's a UK map, draw the Thames, now draw the M4 or whatever, you choose your favorite motorway, see who wins.
Yeah.
The Thames is gonna win.
I feel like
I would say.
Yeah,
I feel
okay,
like
okay,
you
that would be a good user
overestimate how
study.
much accuracy people would have with either of those. Just like,
The Thames, goes through London, but then you go, okay.
you just start in London and then just pick a random
So it
direction.
goes up to Oxford,
Yeah.
doesn't it? And they,
That would be a fun user study, but yeah, that would be in the ideal world a user option,
yeah.
like roads.
I was just going to say, I was thinking about saying it, but I said something else instead. Another question I was going to bring up was the idea of a 2D space, like a topological feature, because you're using a river and you only show the other river, which is kind of, it's in a 2D space, but it's one-dimensional, it's a line. So how would it work with 2D space? You might want to answer for that.
I'm not quite understand what you mean.
So if I wanted a square,
Yeah.
like a box.
Well, square is just four
Or a lake.
edges. Square is just four edges. So
Yeah, I know, but how would the algorithm work? Basically.
Yeah, that's future work. Like adding more features is future work. But in principle, it would be. Well, actually, I mean that is something you'd want to have an answer for.
That's what-
Is how would the algorithm change or have to be modified to add more topological features?
Yeah, I was thinking how to add more topological feature. Yeah, for that question,
I think it would just be the test river intersection and using multiple criteria.
yeah, if there are multiple topological feature, one possibility is we not fix the position of the topological feature. It also can be pushed by the other topological feature, so that can work with current algorithm.
That's a good answer.
Any other ideas? We did talk about it.
Yeah, very.
Yeah. The other one was fixed start and end points.
I mean the pushing region.
When you can manipulate the boundary, but it always has the same
Oh,
start
right,
and end
right.
points.
My answer would have been the the part of the algorithm where you're pushing other CCGs out of the way has to be modified to be to be very localized.
Oh.
Because you can push CCGs that are way far away from the Thames River, which doesn't really make much sense. What if there's another river there and you're pushing CCGs across some other river?
Yeah.
That would be
Well,
not good.
that would just be a massive problem.
Yeah, exactly.
You just cause the deadlocks.
Yeah, you'd have it wouldn't work. It wouldn't be great.
You're just adding more constraints with more features, aren't you? And I guess it must come to a point where you got so many constraints that you can't do anything, basically.
Well, that's when we finish.
Well, yeah. Well, we can't even start though. We just have the map
Well,
as it is.
that's when you finish.
Yeah, that's
There's
true.
nothing showing.
But it actually makes sense, because the more topological features you add, the more accurate it becomes. And so the more accurate it is, the less room you have for change. Okay, I guess in the interest of giving Mohammed some time for his, we should move on then. Thank you, Chao. Don't be afraid to take notes.